Section 10.5 has us working with graphing and analyzing quadratic equations. We're going to be spending a bit more time looking at analyzing these quadratic equations more than graphing them, because graphing is something we've covered in previous videos. But analyzing is something a little bit new and different, and we're going to go through the different things that we are going to be looking for in these quadratic equations and how we can get to those answers. So first and foremost, we need to start off with our quick reminder. Quadratic equations, they are second degree polynomials, meaning that the highest power for an exponent that we see is 2. So we would at most see an x squared or a t squared or n squared, something along those lines there. The graph that these things create is generally U-shaped in nature. So as a quick drawing here, we had a graph, a parabola, which is what the name of these things is called, would be something like this. It's got a U shape going up, or it could be a U shape maybe going down, something like that. Where exactly it's positioned in this whole graph, or this set of axes that we have, it can change, it can vary, but it's going to follow this general U shape that we have here. Now, with this analysis and analyzing of quadratic equations, I'm going to make it clear here at the very beginning, we're going to have a lot of things that we're going to be going through. You're probably seeing a fair amount of these right now. There's more that's down below, but a lot of these are meant to be fairly small or quick things that we can solve, and or we're bringing in a lot of previously learned material into this section and just applying it to quadratic equations and seeing how it all links up and goes together. So, the orientation of a parabola. Is this thing opening up, meaning we have it like that, or is it opening down like we saw with our example there? So, way we take a look at this and we analyze this and we figure this out is we need to first determine what is the a value of our parabola. And by a value, I'm referring to having this thing written in standard form, this ax squared plus bx plus c. So I need to figure out what is this a value. If this a value is something greater than 0, meaning it's positive, then this parabola opens upward. If the a value is less than 0, then the parabola opens downward. We get that upside down u or an n or something of that effect there. And congratulations, that's all we look for with this a value. That tells us if this thing's opening up or opening down, and that's all there is to it. Not a whole lot beyond that. Our next part that we have is working with the vertex and the axis of symmetry. Now these two things kind of sound very different from one another, but it turns out they're actually very similar, and we actually use a lot of similar information for them. So the axis of symmetry is the vertical line that divides the parabola equally in half. I think it's a great thing to take a note of, so I'm going to highlight that there. And I would recommend that you write down this equation for the axis of symmetry as well. And again, this is referring to and coming back to our standard form for quadratic equations with this a, b, and c value. So with these parabolas, again, it's kind of a U shape that we have here. The axis of symmetry is this spot right in the middle that cuts this thing in half and shows that the left side is the exact same and equivalent to the right side, which, as the name would suggest, means that this equation in this graph is symmetrical. So the axis of symmetry is, again, that thing that cuts my parabola directly in half. That's the thing right here that I'd be looking for. So how do I find that? I just take my a and my b value, I plug them into this equation here, and that's just going to give me the answer. That tells me my axis of symmetry. It's in the form of a vertical line, and I'm good to go. Done right there. But if we go a step further with it, the vertex of our parabola, and again, I'll do it in an actual more permanent red that will stay here rather than the laser pointer. There we go. So I have this thing. The vertex is going to be the highest or the lowest point on this, and it's generally at the very bottom like we would have right down here. Well, it turns out that that vertex is going to lie directly on this axis of symmetry. It's right at the lowest point, and the lowest point is going to have to be right in the middle of this overall graph, which means it has to lie directly on this axis of symmetry. So, as it turns out, We are again using standard form. The vertex of our overall parabola is going to be of the form, the b value, or an x value I should say, of negative b over 2a. So what's kind of nice about this is the x value of the vertex is the same thing as the axis of symmetry. So these two go hand in hand together. If you know one, you can automatically jump to the other. The frustrating one is the y value of this thing. There is unfortunately no shortcut, for lack of a better way to put it, to find out what this y value is. That's why we have f of negative b over 2a. What this means is once I have found the x value here using the shortcut, I'm going to take whatever that number is, whether it be a positive, a negative, a fraction, a decimal, or 0, whatever that number is, and I'm going to plug it right back into my overall equation. I'm going to plug it in for x here. I'm going to plug it in for x here. I'm just going to go through and calculate it down to find an overall number at the very end there. And again, that number could be a positive, it could be a negative, it could be a fraction, it could be a decimal, or it could be 0. We don't know. It's just going to be some number coming out of this. And last but not least, we can sometimes also be asked about the minimum or the maximum value of a parabola. Well, as it turns out, the minimum or the maximum is going to be the vertex, specifically the y value of the vertex. So right down here with our example, this is where the parabola gets to its lowest point, right at that vertex. So the y value here would be the minimum of my overall parabola. So the vertex is a really handy point to get because it tells us both the axis of symmetry and minimum or maximum points if the question or set of questions is asking us to calculate that at all. Let's keep moving on down here to our other parts we have. So looking at our two intercepts. Oops, I don't know why x-intercept is not highlighted. It's a big one. We need to have these. So x-intercepts, as a reminder, are where the parabola, or really any graph, intersects either by touching or going directly through the x-axis. It is always of the form some number and then 0 for our y values because it's always crossing the x-axis. The x-axis always has a y value of 0. Now the way we can go through and solve for this thing is we have a lot of options at our disposal, and they are all listed right down here. These are all things that we have covered previously, so all of them are fair game. I do think it's a good practice to start with trying to factor those things, or factor the equation that's been given to you. If that is possible, that could make life really, really easy to find the x-intercept or x-intercepts. If we have something written in vertex form, then I think extraction of roots is very, very, very quick and gets us to our answer in no time at all. Completing the square, it's not bad, but I find that it takes a bit longer than some of these other methods. And if all else fails, you're unsure of what to do, get everything into standard form and then just use the quadratic formula. That will always tell you the number of x-intercepts that you have and what they are. Now, to that point of the number of x-intercepts that we have, this is a thing that gets a lot of people with these problems. So if you're taking notes on this, I would highly recommend that you put some red stars around this to make note of it for yourself. With any of these graphs, we could have 2, 1, or no x-intercepts at all. Again, if we're thinking on the general shape of these things, I'm just quick handing this. I could have something that is way up here. It never crosses the x-axis. Or I could have something showing like that, where it would cross the x-axis twice. Or maybe I have something where it just comes up and it touches the x-axis and goes back down, or the reverse of that as well. So all of these three possibilities are perfectly eligible in a problem. A lot of this just comes down to the nature of the problem and the equation that you are working with. There's not really any trick to guarantee that you're going to always have 2 x-intercepts or 0 x-intercepts or 1 x-intercept. It's all based on the problem that you've been given. The quadratic formula, again, is a very handy way of going through and determining if we will or will not have those. But these other methods could be faster in different scenarios, depending on the form that the question is given to us in. Last and certainly not least, with our y-intercept, this is one that we will always have for every single parabola that we are working with and analyzing. Remember that the y-intercept is the place where the parabola, or really any graph, intersects the y-axis. This is where it crosses that vertical line axis that we have showing up there. The way we go about solving for this, we just plug 0 in for the input value of the equation. Generally that's x, but it could be something else. We plug that into the equation and solve for the corresponding output. Again, as a reminder, you will always have a y-intercept when you're analyzing a quadratic equation. You might have an x-intercept if you're analyzing one of these things as well. So just keep that in mind for yourself. The y-intercept is guaranteed. The x-intercept is not. Now, our last part here is basically just touching on this material just for the sake of noting it, but we are going to go into more examples of how to analyze graphs rather than going through and graphing these things. So if you are going to graph a parabolic equation, there are some requirements that we need for graphing pretty much anything. We want to make sure we're labeling our axes. This is x and y, this is t, this is h of t, this is a, this is b, something like that. And then make sure we have the axes scaled appropriately. Am I counting by ones? Am I counting by fives? Am I counting by threes? Whatever that might look like. So make sure we have that labeled and set up for ourselves, because if we don't have that, well, we could graph something horribly wrong and it all falls apart there. At the end of the day, if you're ever wondering how we can go about graphing parabolic equations, this is our bare bones requirement right here. We want to graph the vertex, and we want to graph 2 points to the left of the vertex and 2 points to the right of the vertex. At the end of the day, it doesn't matter what those 2 points to the left are. It doesn't matter what those 2 points to the right are. They could be intercepts like we were discussing up here. Maybe they are randomly selected points. Maybe it's a y-intercept. It truly does not matter. At the end of the day, it's the vertex, 2 points to the left, 2 points to the right. The one I have listed here is just a proposed process that you could use. It's by no means a perfect one, and it's by no means going to guarantee that it will always make these 5 points that we're looking for very easy to find, but it is something that you can use. So we can first start by finding the vertex. So we're going to use the quadratic equation, or we're going to be given something in vertex form. Maybe it's given to us in a factored form. I think getting it to standard form is very helpful. That way we could find the vertex fairly easily with our methods that we discussed previously. If something's in vertex form, like we have right here, and if you don't have this written down, I would say making a note of this is very, very handy, because this is another very, very helpful form that we see quadratic equations in. If we're given something in this form, then the value inside the parentheses is my x value. The value at the very end here is my y value. And there I have my vertex. Good, done. We want to determine the orientation of this quadratic equation next. Is it opening upward? Is it opening downward? Just give us a general shape of this thing. Once we have the vertex, we've already found that. Maybe it's given to us in that form, or maybe we're doing some rewriting here, but we have the vertex. I think it's very helpful to find the y-intercept as you're going through this, because you're always going to have one. And then you could find the x-intercept and use those if you'd like to. If we don't have x-intercepts, then okay, it's up to us to then pick 2 points to the left of the vertex, 2 points to the right of the vertex, and then just plot those points and connect them together. Again, there's a lot of options and variability with how you want to go about plotting these parabolic equations. This is just one process that you can use. You look up anything online, you could probably find a lot of different tips and tricks that people might have with it. But at the end of the day, it really does come down to this one line that we have right here. Get the vertex and determine 2 points to the left and then 2 points to the right of it. Plot those points and connect them together to get something about like that or about like that there. So with that, let's jump into a couple examples of actually going through and analyzing quadratic equations. So I'm going to zoom in, or scroll us down here a little bit. And these are the 4 examples we're going to look at. If you need to, I'd pause the video here, write these down for yourself, because these are the things that we are going to solve for in our 4 equations that we have here. So let's jump into those now. Let's get started here with our first example. We have f of x is equal to x squared minus 8x plus 12. I have a through f listed here, and if you need that reminder on what we are looking for each of these parts of the problem, I'd go back a couple seconds in the video, write those down for yourself, and then come back to where we are now. So, first part with this problem, we are asked about, for part A, to find the orientation of this graph. Is this thing opening upward or is it opening downward? I think a great place to start with this, because again, we need to find the a value of this thing. That's the thing right in front of the squared term. Could be worthwhile to start off with saying, I've got this thing in standard form. I'm just going to find my a, b, and c values right now. I'm going to need them eventually. I might as well get them all out. So my a value, that's the thing in front of the x squared, that's going to be 1. My b value is going to be negative 8. My c value is going to be 12. Okay, I'm still looking for the orientation of this thing. Is it opening up? Is it opening down? I'm looking to my a value. The note said that if my a value is greater than 0, meaning it's a positive number, that this thing opens upwards. 1 is greater than 0, so therefore my answer for a is this thing has an upward notation, or orientation, I should say. You can say opens up, upward, depends on what your instructor is asking for, but upward works just fine here. Part B is asking for us to find the axis of symmetry. So as I'm going through and doing that, remember our axis of symmetry has the equation x equals negative b over 2a. And again, I have my a and b values already calculated and determined up here from my original equation. Great, I can plug these into this equation here and find my axis of symmetry. So I end up getting x is equal to negative 8 over 2 times 1. Go through and simplify this thing down. I'm going to have this negative and negative cancel, so I'm going to have a positive 8 over 2. 8 over 2, that's going to give me an x value of 4, which tells me that my axis of symmetry is at x equals 4. Perfect. Part C is asking for me to find the vertex. Now the great part about the vertex is the axis of symmetry that we just found right here in this part of the equation actually tells us the x value of our vertex, which is fantastic. So we have half of this answer already done. The unfortunate part is that we do not have any kind of a shortcut to find this y value. So the only way we can do that is to take this x value of 4, plug it into the equation for x, and solve for what comes out of this. So I'm just going to write that down. I have f of 4 is equal to 4 squared minus 8 times 4 plus 12. Working through this thing, I'm just doing number crunching. You can do this in your head if you would like to. You can do it with a calculator. Oops, this should be minus 32. Maybe. There, it's erasing. Then I have 16 minus 32. That's going to give me negative 16 plus 12. Negative 16 plus 12, that's going to give me a negative 4. So great, I have the y value as negative 4. And I'm going to bring it back over here and write in my vertex as 4, negative 4. Perfect. Part D is then asking to find the maximum or minimum of the equation. And again, this is another one where I'm looking at the vertex and I'm just going to use the y value here. Because this thing is opening upward, I'm going to have a minimum value. I can't have a maximum because it would open up forever. Or keep going up forever, I should say. So this thing has a minimum value. I'm just going to say min for shorthand. You could say max for shorthand for maximum if we see one of those. I'm going to say minimum, and what is that minimum value? It's going to be negative 4. It's the lowest point that this thing gets in the entire problem. Now, Moving on to part E, this is the one that can be fairly time intensive depending on what values and numbers and forms we've been given originally. But E is asking us to find the x-intercept. I'm going to scroll us down here a little bit to provide a little bit of space. Now if I'm finding the x-intercept, I should say, remember that is always where the y value is equal to 0. So I can plug 0 in for f of x. I'm writing out the rest of my equation. And now I am solving this thing for 0. As we mentioned previously, there's about 3 or 4 different methods that we could go through to solve this thing. At the end of the day, if your instructor does not specify a particular method that they want you to use, you can use whatever you would like to find the x-intercept. For this one, I always like to say, and I think with a lot of these, I recommend starting off with seeing, can I factor this equation at all? Sometimes we can, sometimes we can't, sometimes we can, but the numbers are really gross and terrible and we just don't want to deal with that, and we can use an alternate method if we'd like to. This one, thankfully, it can factor and the numbers aren't too terrible. I need 2 numbers that multiply to give me a positive 12 and add together to give me a negative 8. Well, numbers for that are going to be negative 2, and negative 6. So great, I have these 2 factors. I want to find what value of x when plugged in here gives me 0, and what value of x when plugged in here gives me 0. So I need to split this thing apart. At least this is one way you could go about doing it. X minus 2 equals 0, and x minus 6 equals 0. For my first one, if I'm adding 2 to both sides, I'm going to get x equals 2. Fantastic. For the other one, I'm adding 6 to both sides, and I'm getting x equals 6. Great. Now I'm coming back up here. It's asking me for part E. I need to write out the x-intercept or intercepts with this. When you are asked to do this, make sure you are actually writing out the x-intercepts as x-intercepts. We can't simply say 2, 6, because that could be misinterpreted as the point 2, 6. So we need to actually write out 2, 0, and then the point 6, 0 as well. This is something that is a very, very common occurrence for people, is they will just leave it as x is 2, x is 6, or they'll do something like, again, 2, 6 as an answer. And again, it's not obvious that this is 2 separate points. It could be that 2, 6 is actually a point on the graph somewhere. So we need to make it very, very clear that we write it as an x-intercept. Okay? Now our last part we're asked to do is to find the y-intercept for this thing. I'm going to move us over a little bit to the right here. Whoops, be in blue. I guess a different color wouldn't hurt. We'll do that for some of the next ones. So for the y-intercept, remember the y-intercept is where our x value is 0. So I'm plugging in 0 for x. 0. So I have 0 squared minus 8 times 0 plus 12. And this is a really nice one to calculate because, hey, this becomes 0, that becomes 0, these are gone. And what am I left with? 12. So what is my y-intercept, or I guess f of x intercept? Coming back over here, I'm writing this in as 0, 6, or sorry, 12. Looking at the wrong numbers on the screen. Don't make my mistake. Don't look at the wrong numbers. Look at the right ones. And here we have each of our final answers. So again, big thing to keep track of as you are going through these. Make sure you are actually answering what it's asking for and writing it in the correct form that we need to, especially with these x and y intercepts. If they ask for ordered pairs, you need to give them ordered pairs. Our second example here is y equals negative the quantity 2x minus 1 times x plus 7. We have our same a through f showing up here. Big thing I want to note with this problem, and this is going to be the case for all of our future ones that we're going to see, we do not need to go through and answer these problems, or these questions, sub-questions I should say, in A through F order. Sometimes the way the problem or the equation is presented to us means, hey, it actually could be easier to start with calculating part D, or part A, or part F accordingly. So just going to note that because we're going to jump around a little bit with our different things that we're solving for based on the information given to us. So currently, this quadratic equation is factored for us. It's something times something else. If I were to use the distributive property, which we will use later on, I'd be getting 2x squared. The negative out front would give me a negative 2x squared. Okay, so I'm going to still have a quadratic equation, which is good. But because it's fully factored, I use factoring to help me find my x-intercepts. So before I do anything else in this problem, find A, B, C, D, E, I'm going to find the x-intercept because that's already prepped and ready for me. So like we did with our previous problem, when I factored this thing, I'm going to note to myself I'm solving for my x-intercept right here. I think it's good to do a little bit of labeling and organizing of your work. That way you know, hey, this corresponds with this part that I'm solving for, or this corresponds with that part that I'm solving for, something like that, just so we don't get things too mixed up. So I'm splitting this thing up, each individual thing in parentheses equaling 0. Perfect. Our first one, I'm adding 1 to both sides. I get 2x equals 1. And then I need to divide both sides by 2. I don't want 2x, I want a single x. So I'm getting x equals 1/2. For the other one, I'm subtracting 7 from both sides, and I'm getting x equals -7. So my two x-intercepts down here for part E are going to be 1/2, 0, and 7, 0. Fantastic. The one that generally tends to take the longest, it's already done and we're good to go there. Fantastic. Now, from here, it's pretty much our choice as to which thing we want to work with next. I'm looking at this and I'm seeing, well, I'd have to plug in 0 in here and then I have to do some extra math. You know what? I'm just going to rewrite this thing into standard form at ax squared plus bx plus c, because that's going to be helpful for these other ones. Factored form doesn't really help with the orientation too much, and I think there's potential room for misinterpreting, especially if there's a negative snuck into these parentheses in here. So I'm going to rewrite it, and then we'll go through the rest of these things in standard form and jump around as necessary. So I'm going to, we'll use pink here to highlight we're doing something different, or separate some of our work out. So over here, I'm just going to rewrite this thing, and I'm just going to use the distributive property and multiply all of this together. So, following that, I would have 2x times x. That's going to give me 2x squared. I have 2x times 7. That would give me 14x. I have -1 times x. That would give me minus x. And I have -1 times 7. That would give me -7 there. I'm going to combine like terms inside this set of parentheses. I'm getting y equals negative the quantity 2x squared plus 13x minus 7. And then I'm going to distribute this negative through at the very end. You could do this negative earlier, but I like leaving it just because it's one sign change that's going to happen for everything versus, okay, it changes here, but does it change there? And I think it gets confusing. So we're just going to leave it to the very end, like we're doing here. Make it negative 2x squared minus 13x plus 7. Great. So now I have this thing in standard form. And when I get that, I always like writing out my a, b, and c values. So I have a is -2, I have b is -13, and I have c is equal to +7. Excellent. Now I can start answering a, b, c, d, and part f from this form here. We started with the x-intercept. Let's keep the trend of working with the intercepts alive. Let's say I'm going to plug in and find my y-intercept here. So let's just do that right below the x-intercept. So my y-intercept work is going to go right here. We remember that we are plugging in 0 for x to find that, so I have -2 times 0 squared minus 13 times 0 plus 7. These first two things will cancel out entirely, and I'm getting a y value of 7, which means that my y-intercept is going to be the point 0, 7. Great, we've got two of these things done right off the bat. Let's take a look at some of these other ones here. We're asked about the orientation for part A, and we're looking at A in standard form. That's a negative number. That tells me this thing is going to open downward. So if we were graphing it, it would be looking something about like that, an upside down U or an N, or kind of about like that there. Now, B, C, and D, we're asked to find the axis of symmetry, the vertex, and the maximum. Again, these three things all go together pretty well. I think it's worth at least labeling which one we're solving for first or second. So I'm going to find the axis of, I'm going to shorthand this, axis of sim. Sounds like a character from something, I don't know, maybe. The axis of symmetry. X equals -b over 2a. Oops, let me put that negative out front like we had it in our notes. If the thing will let me do that. There we go. And I'm plugging this a, b, and values that we found previously in here. I'm going to have this -13 up top. And then I have -2 down below. I have a negative and a negative here. Well, we've got a negative out front. I'll just leave it for now. We'll deal with the signs in a second. Top is going to stay as -13. The denominator is going to become -4. Awesome. Now we can deal with these signs. I think it's a little nicer to deal with them once all the other operations are done and taken care of. So I have a negative and a negative make a positive. So this part is positive. I have a negative in front. The negative times a positive means that this thing is going to end up being overall a negative fraction. So I get x is equal to -13 over 4 for my axis of symmetry. I'm going to go back up to my work here, my answer spot. I'm going to put x is -13 over 4. There it goes. And remember, that's also the first part of our vertex. So I already know half of C. Now I need to find the other part of the vertex, the y value, which that's the one that's going to get a little painful here. We've got a fraction showing up, and it's not exactly a nice fraction, so this might take a little bit of work with the calculator here. I'm going to do the actual number crunching off screen, but I'm going to at least write in what we're doing for our setup. Okay, and then I'm going to number crunch all of this to get to my final answer. I am using a calculator off screen here, so if you're wondering where these numbers are coming from, I'm just calculating them off screen, so. And so we now have our y value for the vertex, this 225 over 8. It's a really gross number that we have here with this. And again, you're welcome to use calculators along the way with these problems. I highly recommend you do that because these things get gross. I'm just going to list that in there. And now we just need to determine the minimum or maximum value of this equation. Because this thing is opening downward, remember that means we're going to have something shaped about like this. Well, maybe. There it goes. Which means that this vertex is going to be at the highest possible point. So that means I'm going to be listing in that I have a max of, and then what is that value? The maximum value is the y value of the vertex. So I have a max, and that's going to be 225 over 8. So hopefully we're seeing with this example here that the order that we go through and solve these things really doesn't matter as long as you're keeping your work organized for yourself and you know how these pieces of information relate to one another, using one to find the others, and things like that. So as we go through some other ones, the ordering that I'm solving them in might be different than the one that you're trying them in, but hey, as long as you're getting to each of these answers that you're being asked for, you're good to go. Okay, so let's take a look at kind of a weirder looking initial problem that we have. So we're given h of t is equal to negative t squared plus 9t. We don't have anything listed here at the very end, so let's see how that affects our process and how we're going through this thing. So again, we have all of our things that we're looking for. It's our choice on which one to start with. If we can, looks like our a value, this thing we have out front here, is a negative, so that means that this thing is going to be opening downward. Again, you can do what we did with our previous problems, which is say I'm going to identify my A, B, and C values first. Nothing wrong with that. A is -1, B is 9, and C, I don't have anything out here for C, so I have to write that in as 0. This is a fairly regular occurrence with a lot of these problems, so don't be too freaked out if you just see two terms here, a squared and a linear term. Nothing wrong with that. It does happen from time to time. So let's say, okay, well, y-intercept might actually be pretty easy to find here. If I plug 0 in for t, well, what's going to happen here? That's just going to become 0. That's just going to become 0. We kind of don't really need to do any extra math with it. A t value of 0 means that this whole output's going to be 0. So what's my y-intercept? It's just going to be the point 0, 0. Make that a better 0. That kind of looks like a 6. If this thing will let me, right there it goes. Okay, 0, 0. Cool. So we have our other parts here. We can go through and solve this however we want. You know, I think I might be able to factor this thing. I'm going to start with finding the x-intercept after that, or after our y-intercept here, because why not? Should be able to factor this. Remember, with the x-intercept, I'm plugging 0 in for the output here. So I get 0 equals negative t squared plus 9t. Okay, so what can I factor out from both of these? Well, I could factor out a negative t. I don't like my leading term being negative if I can help it, especially with factoring. So I'm going to factor a t out from both of these, and I'm going to factor a negative sign out, or a -1. So that means I'm going to have negative t out front. This negative t squared becomes t. This plus 9t becomes minus 9. Because remember, I'm factoring not just the t out, but I'm also factoring this negative sign, which means both of these signs will change inside the parentheses. So cool, I have this thing fully factored. I can split this apart into the instance where negative t equals 0 and the instance where t minus 9 equals 0. Now, my first one, I don't want negative t, so I'm going to just multiply both sides by -1. You could also divide both sides by -1. That will do the exact same thing. We should be getting t is 0 for our first one. Okay, what about the x-intercept over here? Or I guess the t-intercept, but same idea. I'm going to be adding 9 to both sides. I'm getting t is equal to 9. Awesome. So I now need to write this thing in as two individual points. I have two answers here, so I need to list both of them. So I am first x-intercept or t-intercept is going to be at the point 0, 0, and my second one is going to be at the point 9, 0. Excellent. So we got about half of this thing done. Let's take a look at our next part here, the vertex, axis of symmetry, and the maximum. Okay? We do have this thing given to us in standard form. It's just, albeit a weirder one, because we're missing this c at the end. So let's go find that axis of symmetry, because that is also the first half of our vertex. Kind of get 1.5 things done at a time. See if I can make this a little bit neater there. There we go. Axis of symmetry. Remember, that uses the equation x equals negative b over 2a. Thankfully, I do have my a and b values listed up here. Awesome. I can just write and plug those things in. So I have b is 9, I have a is -1, plug that in there. I'm getting x is equal to -9 over -2. I have a negative and a negative showing up here. These two negatives make a positive. So I'm getting x is equal to 9 over 2 for my axis of symmetry. Okay, can plug that in for our final answer here. And again, the axis of symmetry is the first part, the x value of the vertex, so I can also plug that in here. Whoops, don't need the parenthesis, it should be a comma, but I just have the x value of my vertex listed right here. Fantastic. Now I need to actually go through and find the rest of the vertex, so I am, similar to our last problem, I'm going to write out my process right down below here. The calculations that I am doing are going to be on a calculator off to the side. If you're wondering where any of those numbers are coming from, you are welcome to do it by hand or with the calculator. It's your call. But that's how I'm getting these numbers here. And I'm getting an output value of 81 over 4. So I can come up and write that in up here. Oops. 81, not 18. 81 over 4. Perfect. Now I need to determine, do I have a minimum or a maximum value? This thing is opening downward, so again we should have something that looks about like this, which means that this vertex is going to be a maximum value. And what is the maximum value? Well, it's going to be the y value of the vertex, so I get 81 over 4 here. And there we have everything for example 3. Hopefully, as you're going through and trying these things, if you're pausing the video before I go through them, hopefully you're doing them in some different orders than I am, just to see that we can do it in pretty much whatever order, as long as we're getting to the same final answers at the very end. And here we are at our last example with analyzing quadratic equations. So we're starting off with y equals x squared plus x plus 3. And again, we have our same things that we're solving for this problem. So again, I think it's not a bad spot. Let's go back to what we did at the original problem. Let's just start with finding our a, b, and c values. It's always good, especially if it's in standard form. A is 1, b is 1, and c is 3. Our standard form here. So which way is this thing open, upward or downward? A is positive, so this thing opens upward. Looking for the vertex of this thing. Okay, well I have my a and my b value. Vertex and axis of symmetry, again, they go hand in hand, so I'm just going to start with finding the axis of symmetry first. So it's going to be x equals negative b over 2a. I'm just plugging in my a and b values accordingly. I have b as 1. I have a as 1 also, which means I'm going to have an x value of negative 1 over 2, or 1/2, negative 1/2, for my final answer here. And again, the axis of symmetry is also the first half of the vertex, so I can write in negative 1/2 as the first half of my vertex point here. Now coming over to the other part with this, if I'm solving for the rest of the vertex, and I'm getting a y value of, whoops, should be a positive, 11 over 4. So I have my y value of my vertex is 11 over 4. Looking at my minimum or maximum value that I'm going to be having, this thing is opening upward, so it's going to be following that. Then the vertex has to be a minimum value. So I'm writing in that I have a minimum value. What is that minimum value? That's the y value of the vertex. That's this 11 over 4. And there we go. Vertex, axis of symmetry, minimum, maximum, all figured out. Cool. Let's move on to our x and y intercepts. I'm going to start with the y-intercept because that's a pretty straightforward one. Just plugging in 0 for x. I'm going to get 0 squared plus 0 plus 3. That means my y value of the y-intercept is going to be 3. Let's make this a better y. Maybe. There it goes. So I'm going to have 0, 3 for my y-intercept. Little note here. There's my y-intercept work. Cool. Now let's take a look at the x-intercept. Okay, I'm looking at this thing thinking, all right, can I factor this problem at all? I'm starting with y equals x squared plus x plus 3. I'm looking for two numbers that multiply to give me 3 and add together to give me 1. And I'm looking at this, and the only numbers that multiply to give me 3 are 1 and 3. Those two, when added together, give me 4. So I can't use factoring to find this thing. That's fine. That's just how the numbers are. It means we have to use one of our other methods. And I'm going to recommend that we use the quadratic formula because as we're looking at it, I don't think this is exactly one that's going to be fun to use the quadratic formula, completing the square on. It's also not written in vertex form, so quadratic formula is a great fallback if necessary. And right here, we should notice that we are getting something weird showing up under our square root sign. I have the square root of a negative number. I can't have the square root of a negative number and find a real answer. That gives us complex or imaginary answers here. So in the instance where we have this showing up, we remember what it's going to mean for our answer. Well, if I'm solving for the x-intercept and I have imaginary answers, that means that I unfortunately have no x-intercepts. So I can just stop right here, make a note to myself, no x-intercepts. Say, okay, what is the x-intercept for this? Well, we can either write in none or something like we just had down below. No x-intercepts. So cool. It actually turns out that a lot less work that we needed to do for the x-intercept than we were originally thinking. But the big part that I do want to note, if we're looking at this thing, I don't think there's any way to tell from the very beginning of the problem that we have no x-intercept showing up. So lean into continuing to use the process to solve for each of these things, especially for the x-intercept, and let that reveal to you if you're going to have two x-intercepts, one x-intercept, or no x-intercept showing up at all. Again, I don't think it's obvious when we will or when we won't have those, so just let it reveal itself to you. Don't try and predict it, just follow the process and it'll get you there. So as a quick summary and recap of everything that we covered, we specifically went through and looked at analyzing quadratic equations. Remember, we are working with these graphs that are called parabolas. We have our different forms that we can write them in. We had standard form that we used up here. We also had, where was it? Our vertex form written here. And we saw a couple examples that were given to us in our factored form as well. So there are different starting spots that we could be given at the problem. Doesn't matter, we can rewrite it into some of those other ones if necessary. Remember that with the parabola orientation, we're looking only at the a value using standard form. For the axis of symmetry, the vertex and the minimum maximum values, it all comes down to this little set of functions that we have right here. The x value of the vertex is also the axis of symmetry. The y value of the vertex is the maximum or minimum value of the parabola, and it's the maximum or minimum based on the original a value and orientation of this thing. When we're finding and calculating the intercepts, we always have a y value of 0. Any of these listed methods that we have right here are fair game. They will all work, some of them more efficiently than others. We always have the quadratic formula we can fall back on if we make everything or our equation into standard form if necessary. And be aware that the x-intercept can have 2, 1, or 0 x-intercepts in all. Again, I don't think we can predict when this is or isn't going to happen just looking at the original equation. So follow whichever process you're using and let that reveal it to you. And then we have the y-intercept, which is as straightforward as plug in 0 for x, find y, and then we're done there. We did cover a little bit of graphing with parabolic equations, but again, a lot of this really comes down to determining the vertex and then choosing 2 points to the left of it, choosing 2 points to the right of it, and then plotting those on a set of axes. We had an optional process here you do or don't need to use, but there's a lot of other ways that you can go through and do this if you find other videos online or anything in that regard. We had our examples, and I'm going to scroll us down to some group problems or practice problems if you want to give them a go for yourself. I'd recommend pausing the video here if you want to give any of these a try, because I'm going to scroll down here and go to our answers for these. These are our answers to each of our problems. Hopefully you've attempted a couple of these on your own, and hopefully we're getting correct answers, or if we aren't getting correct answers, we're identifying, hey, this is where I can adjust my process there, I can make an adjustment there, oh, there was just a small error that showed up, and we can get those all fixed up. But otherwise, that is everything for the Analyzing Quadratic Equations material.